Hello and welcome. In this video, we are going to discuss the code for the Trie data structure. So before we move forward, I want to let you know that this code is going to primarily consist of two functions. One of them is the insert function and the other is the find function. Now the insert function will be used to insert a string into the trie, and the find function will be used to find whether or not the string that we supply as a parameter is present in the trie. Now that should be pretty obvious. But what I want to let you know is that this insert function is going to be used to build the trie as well. Because building the trie is nothing but inserting all of the strings one by one into the trie. So with that out of the way, let us start writing a class for the trie data structure. So just for the sake of simplicity, we shall keep everything as public. Now let us try to understand what a trie really is. Let us really come up with a definition for the trie. So a trie shall consist of a root node and it shall contain one or more tries as the children of the root node. And with this we have actually come up with a recursive definition for the structure, and it will help us in writing the code. Now it is also essential to know or remember that each of these edges actually contains some data with it. Like say suppose any character like D, E, F, and that is what makes a trie in a sense. So in order to contain all of this information, we shall be making use of an unordered map in C++. So let us keep an unordered map and let it have a character mapped to a trie pointer, and let us call this edges. Let me actually remove this portion. So we are done with it, and we shall call this as edges. Okay, now it shall contain an insert function, and this is going to take a string and an index I, and similarly the find function is going to return a boolean that is true or false whether or not the string is present or not. It's going to take a string and an index I. And this is it for the class definition for the time being. So what is this index I that I have been supplying as the second parameter? So say suppose the string that I supply to str is a, b, c, d, e, f, and I is 2. So in this case what I mean is that I want to insert the substring beginning at 2 up to the end. So essentially I want to insert this string into the trie. That is what it means. This is essential in order to carry out this insertion and find operations recursively, and you shall see why that is the case. So now let us write the actual code for it. So void insert constant string str int I. So the base case for it is if I is actually equal to str of size. If this is the case, it means that this is where my I points, and since I take the substring starting from here to the end of the string, it essentially means that I do not want to insert anything at all because it's empty from here to the end. So we shall not do anything at all, just return nothing, and that's it. Otherwise, let us see what happens. A, B, C, D, E, F. Say suppose I is again equal to 2, so I points to this guy. So what does the state actually mean? This means that there was some trie. We have traveled down the A edge already, that is why I is pointing to this location. We travel down the B edge also, and now we want to see whether or not this node contains an edge which has C in it. So we need to make this check somehow. So in order to do that, we do it this way. If the edges, which is the unordered map of the current trie, dot find str at I is equal to edges dot end. Okay, so this check essentially returns true if this edge does not exist in this node. Okay, and if it does exist, then this condition is going to be false. So let us see what we will do if this condition actually returns true, that is, this edge is not there. So the natural thing to do is we are going to insert this edge. So essentially it's a pair. The first one is going to be str of I, and this guy is going to be a pointer to a new trie. This is it. So now when we come to this location, we are absolutely sure that this node contains this edge, because if it contained from the beginning, then this would return false and we would have been in this location by without any doubt. And if it did not contain this edge, then this would have returned true and we would have inserted an edge and come to this location. So if we are here, we can be sure that there is an edge. So we can now say that edges at str of I insert, because this is a pointer. And what are we going to insert? We are going to insert str, but the substring starting from the next character. And this is the entire code for insertion inside a trie. Okay, so now that we are done with the insertion code, let us see what we will do with the find function. So the find function returns a boolean, and just as before, it takes a string str and an index I. So we know what this index actually is. So let us see. If I is equal to I don't know why I say it equal to, it's simply logical equals. Yeah, so if I equals str.size, it means that we have successfully traversed this whole string within the trie, and therefore the string that we are concerned about actually is present inside the trie. So we are going to return true. Now we are going to see if edges dot find str of I is equals edges dot end. So what does this equality mean? This means again that if this node actually contains the character that I points to at this moment, and this is going to return true if this node does not contain any such edge, and if it does not contain any such edge, then we can return false. And if we reach here, it means that we need to see if the rest of the string is contained within the trie that starts from this location here. So we are going to return the result of the find operation done on this trie. And since we have matched the character at I, we are going to supply I plus 1. And that's it. And another important thing to notice is that the string that we are passing here needs to have the delimiter $ attached to it at the end. Okay, so say suppose if the string that you want to find is this, then before passing it to the find function, you need to attach a $ at the end. And this can be done by some enclosing function that calls this particular function later on after attaching the $. So So that's all for this video, and in this video we have discussed about the insertion and the find functions of the trie.